Hello friends. I am Satish Lele. This video is part of my chemical process piping channel on YouTube. This video is about piping drawings basics. There are two types of views used in the piping drawings, which are orthographic, that is plans and elevations, and pictorial or isometric views. Piping layout is developed in both plan view and elevation view, and section details are added for clarity wherever necessary. These drawings are called the general arrangement of piping. In complex piping system, especially within a unit or plant building where orthographic views do not illustrate the details of design, pictorial view in isometric presentation is drawn for clarity. The Indian standard is 10,711 standardizes the drawing sheets. How to start the piping G8. Obtain the drawings numbers and fill in the title block with the drawing number and title at the bottom right-hand corner of the sheet. Place the north arrow at the top left or right-hand corner of the sheet to indicate plant north. Do not plan drawing in the area above the title block of drawing, as this is allotted for general notes, number and title of reference drawings, brief description of changes during revision and the bill of materials wherever applicable. Process, equipment, and piping have priority on the piping G8. The piping drawings are started after fixing positions of the equipments. Equipment layout is reproduced on the piping G8 with scale and drawn on the reverse side in case of manual drafting. In case of cab, separate layer is used. The major primary beams and secondary beams are also shown if area covered is indoor. Equipment background details which govern piping routing, such as floor drains, HVAC ducting, electrical and instrument cable trays, etc., are also drawn in feet on the reverse. Utility stations are also established so that most convenient utility header routing can be carried out. Order of importance or preference of pipe lines in a piping G8. Alloy steel or special material of construction. Large bore piping. High temperature or high pressure piping. Blind piping. CS process piping. Utility piping. Development of piping general arrangement drawing. The piping drawings should be developed in such a way that all the process requirements are met with. It is not always possible for the piping drawing to follow exactly the logical arrangement of the P and RDF. Sometimes lines must be routed with different junction sequence and line numbers, and subsequently the list may be changed. Performance and economics have to be considered in parallel while deciding the routing. Piping is represented by single lines up to a size of 150 MB and double lines for sizes 200 MB and above. This is to save the time of drafting and to avoid confusion. In single line representation, only the center line of the pipeline is drawn using solid line. In double line representation, the actual size to scale is drawn with center line marked in chain dotted lines. Line numbers are shown against each line exactly in the same way as represented in the P&I diagram. The change in specification should be shown in line with P&I diagram. This change is usually indicated immediately to the downstream of the valve, flange, or equipment. Valve should be drawn to scale with identification number from the P&ID marked thereon. Draw valve hand wheels to scale with stem fully extended. If it is lever operated, then the movement of handle position should be marked. If the valve is chain operated, note the distance of the chain from the operating floor. Show location of each instrument connection with insert number taken from P and RB. Similar arrangement shall be shown as typical detail or covered in a separate company standard as instrument hookup drawings. Draw a plan view of each floor of the plant, and these views should indicate how the layout will look like between floors as seen from top. Utility stations are also established so that most convenient utility header routing can be carried out. Performance and economics have to be considered in parallel while deciding routing. Line numbers are shown against each line exactly in the same way as represented in P and I diagram. Each line should be identified by line number and should also show the installation, tracing requirements, etc. Sections in the plan views are identified by numbers, say 1, 1, 2, 2, etc. and details by alphabets. For example, detail A plant north. The direction should be so selected as to facilitate easy checking of GA with isometric drawing. Lines, if required, shall be broken to show the required details with hidden lines without drawing other views. Do not draw details that can be covered by a note. Draw a plan to a larger scale for any part needing more details and identify it as detail A, etc. Draw part isometric sketches or part elevations to clarify complex piping or piping hidden in the plan view. Full sections through the plant may be avoided if isometric drawings are drawn for the lines. Part sections where required shall be shown to clear the hidden details in plan. Dimensioning of drawings. Sufficient dimensions to be given for positioning equipment and for directing piping. Duplicating dimensions in different views should be avoided, as this may lead to errors if changes are made. Reserve horizontal dimensions for the plan view. Each single pipe is to be positioned for pipe connected to nozzle is to be indicated. Then show the center line elevation and mark the center of the valve. If several pipes are sharing the common support, show elevation of bottom of pipes and mark the bottom valve. This is more applicable to non-insulated lines. In case of several pipes on a pipe rack, show the top of support elevation and mark as to cell. In case of buried pipelines in trench, show elevation of bottom of pipes. Center lines of equipment and pipelines shall be located with reference to building column center lines or coordinates which can be considered as reference base. The distance between the lines shall be dimensioned center line to center line. The horizontal nozzle on the equipment shall be located from center to flange face in plan. For vertical nozzle, show face of flange elevation and for valves, instruments, and non-standard equipment, show the dimensions from flange face to flange face. Flanged valves are located with dimension to flange faces. Non-flanged valves are dimensioned to their centers or stems. For flanged joints, show a small gap between dimension line to indicate gasket. Flanged joints can also be shown without gasket but covered same with a general note and include gasket thickness in the valve or equipment dimensions. For finished floor SF, the elevation shall be the high point of the floor. For foundation, the top of grout top elevation is shown. Show dimensions outside the drawn view. Do not cut pictures. Draw dimension line unbroken with fine line. Write dimension just above the horizontal line. For vertical lines, write sideways. The dimension line can be terminated with arrow heads or oblique dashes. Each series of dimension is to be shown, string them together. Show overall dimension of the string of dimensions. Avoid one of the breakup dimensions to omit repetition and error during changes. Do not omit significant dimension other than fitting makeup. For field run piping, give give only those dimensions which are necessary to move pipe and clear of equipment and other obstruction. Locate only those items which are important to the process. Underline out-of-scale dimensions are marked as empties. Do not terminate dimensions at screws or welded joints. Checking of piping drawings. Checking shall be done only on the print for the checked lot of the drawings and by colored pencils or pen. Corrected areas and dimensions are marked yellow. Areas and dimensions which are to be deleted are marked green. Areas to be corrected or incorporated on the drawing are marked in red. The new print after correction is back-checked for incorporation. Points to be checked on the piping drawing include title of the drawing, orientation, north arrow against plot plan, inclusion of graphic scale if drawings is to be reduced, coordinates of equipment against equipment layout, equipment numbers and their appearance on the piping drawing, correct identification on all lines in all views, line specification changes, reference drawing numbers and files, correctness of all dimensions, whether representation is correctly made in line with the standard symbols or not, location and identification of all instruments, requirements of upstream or downstream straight lengths, insulation requirements as per P and RDS, piping arrangement against T&ID requirements such as gravity flow, seals, etc. Possible interference, floor and wall openings, correctness of scale in case of general arrangement drawings, whether all stress analysis requirements are met or not, adequacy of clearance from civil structures, electrical apparatus and instrument consoles, accessibility of operation and maintenance, space and provision of drop-out and handling areas, foundation drawings and vendor equipment requirements, details and section I identification match line provision and accuracy, presence of signatures and date, accuracy of BOM in isometrics, number of issues and revision. Isometric drawing should also include the following information: dimensions and angles, reference number of P and RDS, GA drawings, line numbers, direction of flow, insulation and tracing, equipment location and equipment identification. Give nozzle identification on the connected equipment. Give the details of plans on the equipment if its specification is different from the connecting piping. Size and type of every valve and direction of operation. Size and number of control valve. Location, orientation and number of each equipment. Field weld which is preferred in all directions to take care of site variations. Can also be covered with a general note. Location of high point vents and low point drains, covered with a standard arrangement note. Bill of material. Requirements of stress relieving, seal welding, pickling, coating, etc. Spools. The spool is an assembly of fittings, flanges and pipes that may be prefabricated. It does not include bolts, gaskets, valves or instruments. A spool sheet is an orthographic drawing of a spool drawn either from piping GA or from an ISO sheet. Each spool sheet shows only one type of spool and instructs welder to fabricate the spool, lists the cut lengths of pipe, fittings and flanges, etc. needed to make the spool, gives material of construction and any special treatment of finished piping. Indicates how many spools of the same type are required. Thanks for learning. If you like this video, please give a like to my channel and